This video is all about the theoretical calculations for heat of combustion. Now we have this formula as the delta H or heat of reaction is equal to the summation of the heat of combustion values for the reactants minus the summation of heat of combustion for the products. Now, if we encounter on the problem solving part with this statement as standard state, we're going to use the value for the temperature at 25 degrees Celsius and pressure at 1 atmosphere. Now let's proceed with our example for this topic as the combustion of methanol. Okay? So we have the decomposition of methanol. CH3OH decomposes into formaldehyde and hydrogen gas. This is formaldehyde, okay, as used in preservatives and preservation of remains, plus hydrogen gas. Okay. Then we're going to calculate the heat of reaction, delta H R or H reaction. Now, if we're going to identify our compounds in this reaction, methanol is actually the reactant, and the decomposition of methanol forms the following products as formaldehyde and hydrogen gas. Now, let's proceed with the solution. For the first step, each reaction and corresponding heat of combustion value is either given away or can be seen in a table. If you're going to encounter problem solving for heat of combustion theoretical calculations, I'm going to give you the stepwise reactions and their corresponding heat of combustion values. Okay, for this problem, it's already given as highlighted on the blue table. We have the stepwise or sub reactions and their corresponding heat of combustion. So we have the first reaction as methanol plus 3/2 of oxygen gas forming carbon dioxide and water. And then we have formaldehyde, combustion of formaldehyde with oxygen gas forming carbon dioxide and water. And we have combustion of hydrogen gas forming liquid water. Now, another trivia here, if we encounter incomplete combustion, the materials form carbon monoxide and water. If we encounter complete combustion, as you can see on the table, complete combustion of materials will form carbon dioxide and water. Okay? The second step after we are given with the table of the stepwise reaction is to rearrange the equations to complete the form given on the problem. Okay? So we need to rearrange the following three given equations. Okay? We need to rearrange it by canceling out the common compounds to give us with our final answer with the given reaction. All right, now let's rearrange the first subreaction as methanol plus 3/2 of oxygen gas forming carbon dioxide and water. Okay, so this is still equal to positive 726.6 kilojoule per mole for heat of combustion. Now, if we're going to reverse the second reaction, as you can see here, carbon dioxide plus water became the reactant, forming the following product as formaldehyde and oxygen gas. If we reverse the species of the compounds of the second reaction, since this value for the heat of combustion of the second reaction is negative, it becomes positive. The same goes with reversing the reaction for the third one. Okay, our reactant now is water and decomposing it to hydrogen gas and oxygen gas. Okay, from the value of heat of combustion of negative 85.84 kilojoule per mole, since we reverse the equation, it becomes positive 285.84 kilojoule per mole. So we are reversing the second and third reaction so that On the third step, oxygen from the reactant of the first reaction will cancel out with the sum of oxygen on the product side of second and third reactions. Okay. So if we reverse reactions, the value of heat of combustion for that reaction also reverses its sign. Okay. Now let's proceed with the third step. We're going to add now the intermediates of this table from step 2. Now, if we're going to add the intermediates of the table from step 2, the 1.5 or 3 halves moles of oxygen from the reactant side of the first equation cancels out with the total oxygen atoms or oxygen molecules on the second and third reactions. Okay, so 1/2 plus 1 of the oxygen of the product side of the second and third equation gives us 3 halves equation. So, or 3 halves oxygen. So it cancels out like this. And the second one to cancel out is the carbon dioxide. Okay, we're going to eliminate carbon dioxide to get this form of the original equation. So the carbon dioxide from the product side of the first equation cancels out with the carbon dioxide at the reactant side of the second equation. And lastly, we're going to cancel out water from the first equation, second equation, and third equation. Okay. Now, this gives us with the following form for the reaction as the decomposition of methanol forming formaldehyde and hydrogen gas. And to determine now the unknown for this problem as the heat of reaction, we're going to add the values of heat here. Okay, so 726.6 kilojoules per mole plus 563.46 kilojoules per mole plus 285.84 kilojoules per mole gives us with the final answer at 1,575.52 kilojoules per mole.